In this video, we will review the service route redundancy in vectors feature. So why use this feature? What is it? The service route redundancy in vectors feature allows for failover of both new and existing sessions across multiple service routes between routers or between multiple next hops of the same service route. We now support non-SVR failover as well, where the non-session smart router is the next hop. With this new feature, we can now prioritize service routes and next hops. We can send traffic to other peer routers. We can have other peer service routes as backups to our primary peer service routes. And we can even have non-SVR service routes as a backup route to our other routes. We can even use peer service routes between two HA routers. For example, let's say the WAN side of our branch is down, but it is still connected to its HA peer. Then we can have it send traffic to the peer and use the peer's service routes as our backup routes. Here's an example of a non-SVR failover use case. Let's say you have two peer routers and a direct internet breakout option where you want to allow failover across all three routes while prioritizing the peer 1 and peer 2 routes over the internet breakout path. You now have the ability to configure vectors on each individual service route on all routers involved. We can also have failover between non-SVR service routes, and we can prefer one over the other using vectors. In this example, our router has a broadband path and an LTE path. We will prefer the broadband path. If the broadband path goes down, however, we will switch over to the LTE path, but when the broadband path becomes available again, we will fail back over to it. Service route failover can be done between two redundant interfaces in a highly available setup, between next hops of the same service route, across multiple service routes to a single peer SSR, across multiple service routes to multiple peer SSRs, and across multiple service routes to a non-SSR using a non-SVR path. We will take a closer look at these configurations in just a moment. In short, this feature allows the same service route to be available on two standalone routers and allows you to assert influence over which service routes get priority. Setting path preference across multiple next hops and across multiple service routes can be done with more convenience and ease using vectors. Therefore, this new functionality should be used moving forward when it comes to designing your service route prioritization and failover. Vectors can now be applied to non-SVR service routes as well. Before we get started, there are a few important things to keep in mind with these configurations. In order for this feature to work, you must configure all service routes to have enable failover set to true. This means that traffic will fail over between those service routes. This includes new and existing sessions. Also, you must configure vectors in order to give preference to one service route over the other. As we mentioned, vectors can now be configured from directly within the service route configuration. Multiple service routes can be configured across multiple routers, each being assigned its own vector. In this example, we'll configure the same service routes to be available on two standalone routers so that we can have service route failover across routers. We assert influence over which service routes get priority using vectors. As we discussed, the priority values for the vectors are configured in the service policy. Then we apply the vectors to the service routes, giving the service routes preference. Note that in case the vector is configured on the service route as well as on the next hop, the more specific one will be chosen for that next hop. The vector configured on the next hop will be chosen. If a next hop has no vector configured, but there is a vector configured on the service route, the next hop will inherit the vector from the service route. Let's take a look at the configuration for configuring multiple service routes. First thing you would need to do is create the service. You can see I have already created the service here. Next, you would create the service policy. First, I will need to set my session resiliency type. In the session resiliency type field, if I choose revertible failover, that means that as soon as my preferred path is available again, we will fail back over to it. I will configure my vectors in just a few moments. Next, I will configure the service routes for this router. I will start by configuring my Boston peer service route. Now I will add the service name, enable failover, and set my vector red. Now I will select a service route type of peer service route, and then I will select my Boston Site 1 router. Next, I will configure my Raleigh service route. I will select the service name, then I will apply my vector blue. I will enable failover, choose peer service route, and will select my Raleigh router. Next, I will add the internet breakout service route. Remember, this service route is going to be for our local non-SVR breakout. Under service name, I will select the web server service. I will then add my vector of internet breakout, and then I will enable failover. This time I will choose a service route type of service agent. Now I will add a next hop, selecting the node and the network interface for the next hop. I will configure my gateway address for this next hop. Next, we'll find our web server service. We can see we already have a service policy configured. If we click Go To, that will bring us to the service policy. I will now configure my vectors. First, I will configure the red vector. I will give this a priority of 1. Any service routes assigned the red vector would be the primary service route. Next, I will configure my blue vector. I will give the blue vector a priority of 10, so any service routes that we apply the blue vector to will be second in order of priority. We can see that the vector field is a free text field where we can manually enter a numerical value. Next, I will add my internet breakout vector. I will give this vector a priority of 100. Any service routes that we apply this vector to would be our tertiary service route. On the service policy, notice we have configured all of our vectors. Also, remember to set a session resiliency type. Now I will validate and commit the configuration. Once you have done that, you can navigate to the Routers menu. Then select the router that you've configured your service routes on. And under Routing Details, select the Service Paths menu and confirm that you have configured your path preference correctly. For example, you can see which vectors were applied to which service routes, and you can also look at the cost column to see which priority the vectors were given. Now that we've reviewed the configuration of having multiple service routes across routers, you may be asking yourself, what happens when you have more than one service route headed to the same router? How do you set preference in this case? You will need to configure a vector at each of the neighborhoods. Then at the service policy, give your vectors priority to set path preference. For example, let's say that from your Seattle router to your Boston router, you have 2 service routes, an internet route and an MPLS route. To prefer one route over the other, you will first need to configure a vector on each of the neighborhoods. In this case, we'll prefer the MPLS neighborhood. Remember, a neighborhood describes the destination of network traffic. So when we configure the vector on the neighborhood, we are indicating which path should be taken to the router. Right now, I have 2 connections between my Seattle router and my Boston router, but I haven't indicated which of those connections I prefer. Let's take a look at the service policy that we've already set up. We have 3 service routes that we've already configured. We have one service route from Seattle to Boston, which we gave the vector red, another service route from Seattle to Raleigh, which we gave the vector blue, and finally, we created a service agent service route with the vector of internet breakout. Remember, vectors give our service routes priority. As a reminder, you will need to set the session resiliency type in the service policy. Since right now I have 2 connections between my Seattle and my Boston router, but I haven't specified which one I prefer, I will need to configure this now. First, under the Seattle router, I will find my peer route to Boston. Then I will remove the vector. Now I am back at the authority level. I will now go into my Boston router. Then I will go to the node level. Then I will scroll down to the device interfaces. I will click on the MPLS1 device interface. I will scroll all the way down to find my network interfaces. I will click on the network interface. Then I will scroll down to find the neighborhood. I will click on the MPLS neighborhood. Under the MPLS neighborhood, I will add the red vector. This will be my preferred neighborhood. Now I will jump back out to the node level. I will click on the WAN 1 device interface. Then I will scroll down to find the network interface. I will click on the Internet Network interface, and then I will find the neighborhood. Now I will configure the vector green. Since we do not already have the green vector in our service policy, I will need to add that now. I will jump out to the authority level. I will scroll down to the service policies, then I will click on the web server policy. I will now add the green vector. I will give this a priority of 5. We gave our vectors priority here in the service policy, and applying our vector at the neighborhood level allowed us to prefer one path over the other when we had 2 paths headed to the same router. Once I commit my configuration, our web server service will prefer the red route, which is the MPLS route going to Boston. Then it will use our green route, which is our internet path going to Boston, followed by the blue route, which is our route to Raleigh, and finally our internet breakout route. In this example, we have 2 separate standalone routers that are configured for high availability, 2 routers each with a standalone node. We will configure both routers so that existing sessions can fail over between them. As we learned previously, we can have multiple SVR paths and multiple non-SVR paths between routers and have failover between one another. But what if you would like to create a peer route as your last resort backup route for all of your other routes? If all of our other peer service routes and non-SVR service routes fail, how can we fail over to the peer service route between our HA routers? We will configure the same service routes on Seattle Site 2 that we have on our Seattle Site 1 router. We are using VRRP for these HA routers. For more information on VRRP, please see our VRRP video. Remember, I have already configured all of my service routes, but now I need to configure my peer service route between my HA routers, Seattle Site 1 and Seattle Site 2. I will configure this on my Seattle Site 1 router now. Then I will scroll down to the service routes and I will click Add. I will name this Web Server Seattle Site 2. I will select the service name, which is web server. I will enable failover so that we can have failover between our service routes. Then I will apply the vector silver. In just a moment, we will add the vector silver to our service policy. Now I will select a service route type of peer service route. And then I will select my peer, which is Seattle Site 2. Going back to the authority level, if I scroll down and look at my web server service, we can see that we have already applied the web server policy. We can click Go To take a look at our web server policy. We are now in our service policy. Scrolling down to the bottom, we can see that we have already applied our vectors. Now I will add the silver vector, which we applied to our Seattle Site 2 peer route. In the priority field, I will give this silver vector a priority of 1000. We can see that any service routes that have the silver vector applied to them will be last in order of preference. We can also see in our service policy that we have already set our session resiliency type to revertible failover. Now all that's left to do is validate and commit the configuration. I will do that now. The next type of configuration that we will take a look at is multiple next hops. With this configuration, sessions can be moved between 2 non-SVR next hops. We will configure one service route that will contain 2 next hops within it. Both of the next hops in this case are non-SVR next hops. Then we will assign the appropriate vector to each next hop to indicate which next hop has preference. If you are configuring 2 next hops of the same service route, Source NAT cannot be enabled. Let's take a look at that now. I will first navigate to my router, then to the node, then to the device interface, and ultimately to the network interface. On the network interface, make sure that Source NAT is disabled so that sessions can be maintained from one path or one next hop to another. If Source NAT is enabled at the network interface, you are telling the other endpoint that something has changed and to tear the session down and start over with a brand new session. If SourceNat is disabled, as we see in this example, that means that we will seamlessly move from one path or one next hop to another, keeping the existing session up. Let's take a look at what we already have configured. I will go back out to the authority level. To configure multiple next hops, you will first have to have your service and service policies configured. We can see that I already have my web server service configured. And under the service policies, we can see that we already have the web server policy configured. Looking at the web server policy, make sure you set a session resiliency type. Notice that I've already configured two vectors under this service policy. I've configured the broadband vector to have a priority of 1, which means that whichever next hop we apply this broadband vector to will be the preferred next hop. We also have the LTE vector, so whichever next hop we apply the LTE vector to will be the secondary next hop. Now I need to apply the service policy to the service. I will jump out one level, then I will find my web server service. Then under the policies section, I will add my web server policy. The next thing I will need to do is configure the service route. I will navigate to my Seattle Site 1 router to configure the service route. Under the service route section, I will click Add. I will name this Internet Breakout. Next, I will select the service name that this service route applies to. Then I will enable failover. I will not configure the vector here, as we will configure the vector directly within the next hop. I will need to indicate the service route type, which is service agent. Now I can configure my next hop. I will select Add next to next hops. I will select the node and the network interface. Now I will indicate the gateway address. We have the ability to give our next hop's preference by applying the vectors directly within the next hop configuration. I will apply the broadband vector here. Applying the broadband vector to this next hop means that this will be the preferred next hop. Now let's jump out one level and add another next hop. I will click Add next to next hops, and then I will select the node and the network interface. I will now configure the gateway address. Now I will configure my next hop vector of LTE. This means that by applying this vector to this next hop, this will be the secondary next hop. Now I will validate and commit my configuration. Jumping back to the service route, we can see that we have now configured two next hops within the same service route. We have given each of the next hops priority by assigning a vector to each of them. Next, we will take a look at the SALT failover use case. Let's say we have two non-SVR service routes to the conductor. If the broadband connection goes down, we'll move over to LTE. When broadband comes back up, we'll fail back over to it. Prior to this feature, we would have stayed on the LTE path, which can get expensive, even when the broadband path came back up. Now, as long as you enable failover on any of the service routes involved, you will have failover between those service routes. In the example you just looked at where we failed back over to the broadband path, that would be an example of revertible failover. We had this feature previously for SSRs only, but now it can be used with non-SSRs and is more straightforward and intuitive. It will fail over whether it's local next hops, peer next hops, or non-SVR next hops. Existing sessions will be maintained. That concludes this lesson on service route redundancy and vectors.